Hello and welcome to another Solana tutorial. Today we're gonna do something fun again. We're going to combine the instruction plans from the previous video with manually deploying a program from another video that I did once, such that we can efficiently deploy a program with the kit without having to run so many scripts. So what I want to learn here is how we can use custom transaction packers to really optimize and at the same time automize the creation of our instructions that we need for deploying a program or writing any kind of buffer account. I'm just going to use deploying a program as an example for writing some data on chain. You could have your own program that just requires a lot of data that you need to write into an account. And I thought about writing my own program with that as an example, but then I was like, no, the better example is to do something that people can actually use, and that is deploying a program. Because, I mean, you're dev. You want to deploy your own programs. So why not learn how to do that efficiently with the kit? Let's go. They see me deploying. Okay, where do we start? So as I said, we're combining two things here. One is the instruction planning with transaction planner and executor that we know from the previous video. So I'm gonna recycle that stuff. And today we're gonna plan to deploy. I'm just gonna import everything from the kit this time. Okay, and then also we're gonna use some scripts that we created when we were playing around with the BPF upgradable loader. I have a video on that. Maybe you wanna watch that first. We go through how to deploy a program. The gist of it really is you first need to create a buffer account, then you need to write to the buffer account, and then you can deploy a program. And you can upgrade once you have already deployed. And really the interesting thing is gonna be the writing the buffer account, because there we will write in chunks. The challenge here is that the BPF upgradable loader is not one of the programs that is supported, I think. I mean, let's check Solana program. Open rep, record, config. There are some more. Stake pool, compute budget. Ooh, loader v3 and loader v4. Maybe there is a pro. I just didn't see, it's just not in this list, but maybe there is. The loader v3, there's a program for that. There's a generated client for that. Because in the previous video, we did all of that manually, right? We created the instructions to the BPF upgradable loader manually by knowing what the instruction IDs are and what accounts I need to provide. But maybe I don't need to do it that manually anymore if I can use this. Let's see what that has. That would make my life a bit easier, and also your life. I understand my code here, but if you have a Solana program loader, why not use that? Template should get you started deploying Solana programs. Nice. Yeah, we have a JavaScript client. Cool. Let's try that. Sure. Forget about my own code. pnpmi Solana program loader v3. That still has dependency on an old version of the kit. It will be fine. I'm also not sure what loader v3 and loader v4 are and what's the one that I should actually be using. I think the upgradable loader is v3, so let's use v3. So from loader v3, let's see what we can get. Close description, close instruction. Yeah, we have all of those. There we go. Nice. That's exactly what I wanted. Perfect. So we can use that and I don't need to go through my manual stuff. Wonderful. Okay, so that's good. And we're going to start with creating a buffer account. No, we're actually going to start with writing a program that we deploy. Let's do an anchor program such that it's a big program to deploy. Anchor init demo program to deploy. And this demo program, how was that something with discriminators? I want such that I can easily call it. I want to have a custom discriminator. Oh man, then I need to look at my own video. How's it done? There it is. Instruction discriminator. Instruction discriminator. Good that I have videos. Let's say 1, such that it's easier for me to call. And then all it does is send me a message. Log me this program was deployed manually with the kit and instruction planning. That's all it does. Good. And we wrote the program. I actually like this program ID. Ice, why not? Ace. We're gonna ace it. Cool. Anchor deploy. Oops, wrong Wrong. I just want to anchor build. I'm going to manually deploy. There we go. We're going to build all of those things just so we can get our SO file. There we go. And this is then what I want to actually write on chain. So this I now want to manually deploy. So let's go. We will start with a simple write buffer. And because I might want to recycle the buffer account, I'm gonna get myself keys for that. And then Solana keygen grind. As usual, I'm gonna get myself a pair. I'm gonna get myself a buffer. And I'm gonna get myself, what else do I need? A program I already have. Okay, set the key pair to the, and airdrop myself some sol. Oh, that won't even be enough. Besides, I can't get it anyway. Oh yeah, wow, I did get 2 sol, but it's still not gonna be enough for deploying it several times. So gotta get some more. That should be enough now. Okay, so we've got a pair and the buffer. Cool. Now those things I recycled from the previous video. It's just a regular transaction planner, an executor that doesn't do anything weird. This one just adds the fee payer, this one adds the block hash, and then it sends and confirms. So not gonna go through that again. Let's go to the actual creation of instructions. And we don't do any sol transfers, but we start with creating the buffer account. And why not writing the buffer account already? Like we did in the, and we can cheat a little and look how we did it in the previous video, in the video about the BPF loader. Why is that called data size? That makes no sense. The actual data. So I'm gonna borrow this, put it here, except this is definitely not data size. This is the program data that we will read from our demo program to deploy, target, deploy, demo program to deploy, SO. So we're reading the SO file as an array. So that's just the data, that's just the bytes. That's the program data. We will log how long it is, why not? If you don't remember what the 37 is, if that confuses you, that's the header. Buffer header size, just so you know what we're doing here. Because into the buffer we not only need to write the extra program data, it also has stuff like the authority and some state, whatever. And that's 37 bytes. So we need to allocate a bit more. And so our instructions will be to create the buffer account with the system program. The new account will be the buffer key pair. I provide the key pair signer here. Actually, I should call this signer, buffer account signer, whatever. The space I allocate header plus how much the program needs. And I create this account for the BPF upgradable loader. Also that I should hopefully find somewhere in here, program ID, loader with 3 program address. There we go. Oh, and while we have a look at it, is that the BPF loader upgradable? Yes, it is. Perfect. That's the one I want. So loader v3, there. That's the create account instruction. This is, I think, the initialize buffer account. But we're not gonna do this manually like that again. We're gonna get initialize buffer instruction, because that makes more sense. I'm gonna set my payer as the authority, and the source account will be my buffer signer address. You require an address. Okay, address. So this and this should be equivalent if I were to write it like this. If you fix that now, that and that should be equivalent. But this honestly is a bit easier to read because we actually know what we're doing here, given by the instruction name. So I'm gonna remove that. Should we check if we can just create the buffer instruction? Let's call them create buffer instructions. And then we make a sequential plan with the create buffer instructions. And that way we could already create this buffer account. I mean, yeah, let's try. Let's go step by step and see if that already works. I'm saying simple write buffer. Really, this is just a create buffer. Let's see if that works. npxt create buffer account. Okay, look at that. Wonderful. So that was the size of the program because Anchor is big. And then we have a, what are we printing here? The transaction, hold on. The transaction plan. It's a single transaction plan because it could fit both of the create buffer instructions into one transaction. So we get a single transaction, and our result is also a single result with this status successful. And then I print it again for myself, transaction successful. So I'm going to remove all of that unnecessary printing. We did have a look at the transaction plans and stuff in the previous video, so I'm not too worried about that. I'm assuming that all of that just works. What's the number that I printed here still? In the thing I print the size, the transaction size. Yeah, why not? Let's keep doing that, but say that's the transaction size. So that one transaction was pegged to 362 bytes. Cool. And like this, we have a buffer account. So all that transaction did was create this buffer account with 1.2 sol because my program is big. So I gotta allocate a lot of data. And that account, we can check, we allocated that many bytes because that's how much we will need to write to deploy an Anchor program that does nothing except do one log. Lol. Okay, good. Let's get to the actual writing the buffer. So same thing, except we're not doing the create. Since we already created that account, we don't need to create it again. So let's throw that out and create the actual instructions that write the buffer. And at first, we're just gonna do it the trivial or easy way and be like, you know what? I'm just gonna say I write 1000 bytes per transaction or per instruction, and therefore per transaction, because how much fits in one transaction? 1200 something bytes, and I need a little bit for the header and the signature. So 1000 should fit, and we're just gonna create my write buffer instructions. We start at offset 0, and while offset smaller than my program data length, we're gonna write 1000 bytes. So we're gonna get write instruction. Is that what it's called? I think it's so. It needs the buffer account, the buffer authority, the bytes, and the offset. So buffer account is my buffer signer address. I could just call this buffer. It's just my anyway. My buffer authority was the payer, and here I think it needs to sign. So that should be the right thing, right? The offset will be my offset, and the bytes. Well, that I need to read from the program data. So program data. Can I access that directly? What is this? Yeah, I should just be able to say offset to, or can I have a sub array? Yeah, sub array is I think safer, because if the end index is out of bounds, then I think it's not an issue. Doesn't say that in the docs. We'll just try. So from offset to offset plus chunk size. Obviously that can get me out of bounds because it might not have an exact multiple of 1000 bytes. In fact, we do know that it doesn't, because that's not a multiple of 1000. So ref calculation, we will need 180 transactions to deploy this. Wow. But yeah, an Anchor program might need 200 transactions to deploy. And now we just push this into this array and say offset increases by the chunk size. There we go. Okay, I could write this cleaner in a functional way, but now I did it in a procedural way, it's fine. Okay, and then theoretically I just need to put the right buffer instructions in my sequential instruction plan. Actually, I could do a parallel instruction plan that will definitely throw off my RPC. I will get so rate limited if I do that. But yeah, that should then, wait, let's see. I'm just gonna log how many instructions I have and how many transactions I will have. Should be the same amount. It should be parallel. Now I should be able to say plans length. That should then contain the single transactions in a parallel plan. Let's return here just to see if that would even build, like if I could even create a plan. Yeah, 181 instructions and 181 transactions. Just for myself, would it fail if I said chunk size of 2000? Yes, it would fail, because provided method has insufficient capacity to accommodate the next instructions in this plan. Nice. Then I get the error instruction plan message cannot accommodate plan. Cool. So we also saw that once. Nice. And here I could optimize how much could I fit in. 1200, probably not. 1100, still not. 1000. So 1000 was actually a good estimate. There we go. So with 1000, they're actually already quite efficiently packed. However, if I now try to send 180 transactions in parallel, this is obviously not gonna work because my RPC will complain, but I'm just gonna show you anyway, because we're now trying to send one. This is not, it's not gonna be happy. But it's fun, it tells me the transaction size, 1218 bytes each. Yeah, and then, oh, invalid instruction data. Well, that's fun. We get a lot of transaction failed for invalid instruction data. That's weird. What am I missing here? It seems like my write instruction doesn't really work. Let's just send one transaction. Let's just put one instruction in there and analyze this. So, execution failed of a single instruction, transaction simulation failed, invalid instruction data. Okay, so even a simple write gives me invalid instruction data. I would assume that the write instruction, I just need to provide the actual bytes that I want to write and not the length of them. I'm assuming that it would serialize that correctly for me. I don't have the implementation here. Write discriminator is 1. I mean, I can analyze it. So, accounts, buffer account, payer account. That's also how we did it when we did it manually, right? Buffer, payer, writable, read-only signer, writable, read-only signer. And then the data is the discriminator. Then 4 bytes of the offset. Wait, shouldn't this be 0? It's twice in here. Wait, oh, did I access 1 and not 0? I accessed 1 and not 0. Okay, so now it makes sense. Then the offset is the same as the length. They're both 1000, here 1000, here 1000. But the chunk length is actually an 8-bit thing. Oh, come on. Did you get that wrong again with the kit? This is so annoying that they have bugs in there. Do they never test this when they publish? I mean, it's also not like the loader v3 is an officially documented thing that they actually say that they have. It's just there. It's not in docs. But maybe that's why that's just wrong. It looks to me like here I'm missing 4 zeros. The vector length is 8 bytes. No, wait, hold on, bullshit. No, they're both little endian. And that's just the offset. Hold on. No, it's fine. It's It's also just a 32 little endian. That's fine. That's here. So that's 1, 1, 2, 3, 4. 1, 2, 3, 4. Okay. And then comes the actual data. But here I have an offset of 16. Let me look at the program again. Loader v3 takes offset and bytes. Write takes offset and that's the length. And then that's the actual bytes. So that should be fine. What's the issue? Let me try to write 10 bytes. How would that look? Same issue. Invert instruction data. 4 bytes. 10 is the offset. 10 is the what we want to write, and then those 10 bytes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the ones that we want to write. So it doesn't look like the wrong data to me. Can I only ever write a buffer sequentially? That would not make sense. Would it? Let's check. What if I say that would not make sense, but let's use number 0 here and number 0 here. And I write simple buffer. Nope, also be invalid instruction data. But then we have instruction 1, offset 0, 10 bytes. Those are the 10 bytes. Why is that invalid instruction data? What am I doing wrong? Why is it saying no? Invalid instruction data. So it's clearly something to do with data. This is weird. Okay, so if I analyze my own code, how I did it last time, then I see that the offset here is 16, but we're just using offset of 12. So maybe the vector length is actually a U64. Maybe this thing here is serialized with 8 bytes. Yeah, my best guess is that the vector of the bytes is not 4 bytes in length, but 8 bytes. So to fix that, I would write instructions map and the data I would overwrite to, I'll do this in several lines. We know that it has instruction data. So I'll add 4 bytes, then how do I copy stuff? Or maybe I'll also just do it here and say subarray the first 4, 8, 12 bytes are correct. So 0 to 12 are correct. Then I want 4 zeros and then I want the rest. It's a bit ugly, but oh well. 12 to, I mean, ugly, but maybe that fixes it. And then return the same instruction but with new data. You think that will fix it? Still invalid instruction data. It does not fix it. But did it do the thing that I wanted it to do? Wait, why am I printing the instruction? Oh, wait, hold on. It doesn't fix anything because I mapped this, but I don't write it to the thing again. I'm gonna overwrite that. There you go. I mean, that's not nice functional programming. Whatever, it's fine. Let's see. Ha! Ha! Okay, I fixed it. But this is so annoying. I don't like, if I call one of those instructions, I expect it to do the right thing and not me having to manually add zeros because you have the wrong length of encoder used in here. So annoying. So another feedback for the maintainers of this library. Could you please fix that and use the correct length for, or am I, the vector, so for this array that's 8 bytes, not 4. Yeah, so I have to do an ugly fix for getting it to work. And I can do that just because I've already played with the program and I know exactly what it's supposed to do. Like a regular dev, like somebody starting out will be like, I cannot use this. This is unusable. So yeah, anyway, it's a bit of a tangent here that we had to fix this. Hopefully in the future that will not be an issue at all anymore because they just fix it. But yeah, that's what you get for using libraries that nobody ever uses and apparently nobody ever tries after releasing them. Yeah, that's what I'm here for. That's just, you know, I found a bunch of those and I will keep finding more of them. So there you go. Yes, please fix that. Thank you. But let's pretend it was fixed and that's just something that would already be done in there. Now we had that fix in here. Okay, fine. With that, we can come back to adding all of our write buffer instructions into our parallel instruction plan and write this entire buffer. Let's see if I can send 180 transactions with my RPC. Oh, whoa, no, hold on. I'm sending 1800. I'm sending 1000 transactions now because I was sending way too many. Hold on. Get it back to the chunk size of 1000. Otherwise, this is not gonna get well. Now we just have 181 transactions. Yeah, that's better. But can I still send them in parallel, or how many of them will succeed? Too many requests. Yeah, that's what you would expect from an RPC, that we just fail a bunch. Too many requests. Yeah, too many requests. But some of them were successful, some of them failed. So that's a bit inconvenient. I could make it easy for myself and use a sequential instruction plan here and send them one after the other. But even then, I think it might at some point get me rate limited. Obviously, this is slower now. And you probably want to either get another RPC that can handle more requests. Yeah, probably that's what you want to do, because then you can run it in parallel. Now I'm running it sequentially, so it's gonna take a while. But therefore, I'm not getting rate limited. That's good. I could also, if that's too slow for me, which, I mean, it is, I need to wait for 100 transactions. I could also check if processed commitment is good enough. Let's make a transaction counter. Can I say plus, plus, plus? Then I don't need that in a new line. Yes. That's ugly code, but here you go. Even with process, it's that slow? Wow. Okay, I guess I need to wait for 181 transactions to go through now. Come on, it can't be that slow. This is not good. How can I optimize this for myself? I want to still be able to do this. Oh, no, now it's faster. Look at that. Maybe I was rate limited. It's still slow. So yeah, doing this sequentially probably isn't the right way to go. Probably the better idea is to do it in parallel and then only send all of the unsuccessful transactions again. But for the unsuccessful ones, I only get the error, not the mess. Wait, do I get the message? Let's say this was single. Then I do get the message. Yes, I always have the message. Okay. So I can build myself a resend, or just get myself a better RPC. I have private ones now, just gonna use those. There we go. Do you think I can now just send 180 in parallel? I can send. Will they go through? Nope. Fetch failed. Fetch failed. Timeout. Yep, I can also not send. Even with this one, I can't send so many at the same time. But some were successful. Maybe even for a parallel plan, my executor should wait a little bit. Wait, but how can I make the executor wait in a parallel plan if it's executed parallelly. I can't really do that, can I? I would need to write my own executor. So here we already find the limitations of what those transaction plans and executors can do without having to write your own one. I can write my own custom executor. Why not? And I'd like to see the source for this. Instruction plan, source, transaction plan, executor. It has a traverse, and traverse will switch the kind, and then traverse sequential, parallel, or single. And traverse parallel is just a await promise all, and sequential is just a await traverse, so that's sequentially, and here it's in parallel. I mean, it's nice. I wish I could just, I can do a quick hack before I implement my own transaction plan executor. I could do a quick hack and say, if I don't manage to do all of them in parallel, I could do, I don't know, always 10 in parallel and the rest sequential. That should give me a good speed up. So how would I do that? Let's say instruction chunk size is 10. I do 10 at a time. And then let's do chunk size step and create parallel plans. Add a parallel instruction plan, offwrite instructions. Oh, you're just an array. I'm gonna get an out of bounds array then. Can I slice this? Can slice that? Yeah, that's what I want to do. And then my instruction plan is a sequential instruction plan of the parallel plans. How's that? This is so hacky. Okay, let's just see if that would, I don't think that would work. But hey, okay, they all got cancelled because one got too many requests. And then the rest all got cancelled. Okay, so I tried to run them in parallel. It worked for 7 transactions, and then I got too many requests and the rest was cancelled. Okay, but the building then works. It's just because I'm running it sequentially, it's still, I need to optimize those numbers, because still 10 in parallel and just waiting for processed. I'm gonna wait for confirmed, and also, no, I'm not gonna add an extra delay. I'm just gonna reduce the number here. Let's try a chunk size of 3 transactions each. This is already way more than I thought. Hold on, I'm not using the right numbers. I'm not using the right numbers. There we go. This is already more complicated than I thought. But yeah, writing 180 transactions is a bit complicated. Oh, that looks better. Look now, but it's still cancelled. Still too many requests. I need to have a way to kind of wait if I get too many requests, no? So that, I guess, I'll have to do in here. I think I'll have to fix my transaction executor to retry itself if it gets rate limited. So we're gonna try send and confirm and catch transport HTTP error and status code 429. Code 429. Then I want to retry, otherwise I want to throw the error. So here we await and promise set timeout. I don't know, a second should be enough. Although it depends how many transactions I'm sending it in parallel. But anyway, I wait a second and then I'm going to do it recursively because I can. The transaction still is the same as here, but I got to somehow return. So, okay. Do you think that's gonna fix anything? Here we're waiting longer, but we might get stuck in a recursive loop. No? Yeah, it's just, how do you deploy? When I say anchor deploy, I also don't have the issue that I need to wait forever. How can I do that without getting rate limited so heavily? Because like this, I won't be able to send 100 transactions. I will, it just takes forever. And it's more and more that are waiting now. I don't know, it's a bit stupid. And it feels like this is even slower than how I did it in the very beginning with the sequential plan. Because with the sequential plan, so 1 each, that was doing one after the other, but that still felt faster than doing them in batches. Yeah, still feels faster to do it that way. But this is still way slower than a regular deploy that you would do with Solana program deploy. They have some other trick, I think, to batch send those transactions. But okay, at least this is working now. I have to wait a long time, but I can get it to the point where I can send all of the transactions, even if I get rate limited quickly. Yeah, wow, that takes a long time to deploy that program. We're 2 hours in and I didn't really get to do any of the fun stuff yet. So we learned that sending a lot of transactions really is a pain, and there might be other tricks to it. But at least that way we can write all of our buffer manually without having to start the script over and over again. It works. It's just slow. But optimizing that, I think I will leave for another time. I want to move on to actually finishing deploying this stupid program. There we go. 180 successful transactions for writing the buffer. Great. So we see, in theory, those transaction planners are super easy to use. In practice, it's a bit more nuanced, because as soon as you have a bunch of transactions that you want to run in parallel and you have rate limits, it's different. But hey, we wrote the buffer. Let's move on to actually deploying the program. Get deploy with data length instruction. Ooh, I knew what the data length was. I don't remember. Authority. That's the program authority. I'm gonna keep my payer as the authority. Buffer account, we have that. That's my buffer signer address, so the buffer account address. Payer account shall be my payer. Program account, now that's interesting. Where do we deploy to? Program account uninitialized. Wait, no, that's the program account. Hold on. Program data and program account. The program data account. Hold on, I'm gonna cheat. The program data account is derived with those seeds, but maybe there's also a get program. Nope, I guess I gotta derive it. And so I'm gonna get the program signer as well, keeper signer, and this guy lives in here as well, except that's the dash key pair JSON. That's the key pair for the program where we deploy to. I'm gonna use that as the key pair signer here, or I call it the key pair signer, so I call it the program signer, and program signer address is the seed for a PDA of the loader v3 program that gives me the program data account. And then I can have program data account and program account, which will be the program signer address. And the authority needs to be a signer as well. Okay, fine. And then we're still missing the max data length. What's that again? I think that was the length of the program data account. So if we efficiently pack, like if we don't expect to upgrade it and make it bigger anytime soon, I can just say my program length. So the program data length. But I can also be like, and we add, I don't know, 1,000 bytes because we might make it bigger. 1,000 is not that much, because if you remember, my program size is this, 180,000. So I could even add an extra 10,000. Whatever. It doesn't matter. I just pay for it. Anyway, so yeah, let's do that. The deploy instruction, and then we do a sequential plan for just the deploy instruction. Lol, I could do a single plan, but whatever. Just to see if I can deploy. Nope. Also, that gives me invalid account data for instruction. Oh, you mother. I hate this. Why does this not just work out of the box? Okay, show me the deploy instruction. We have those accounts. That's the program account. Hehe, it's the buffer. But it's the data anyway that's the issue, right? We said invalid account data. Yeah, wait. Invalid account data for instruction. It's not invalid instruction data, it's invalid account data. I'm providing the wrong accounts. Okay, so that's probably a me issue. So maybe my buffer wasn't written correctly? Or do I need... Oh wait, I think I need to create the program account. The program data account it will create automatically, but the program account I need to create myself. So get create account. The new account will be the program signer. So that's the program account. Payer will be my payer. I assign it to the loader, and then it gets difficult. What's the space? Does the loader have information on the size of a program account? Don't think so. Damn it. So BPF loader 2. What programs do I know? Maybe the invalid account date comes from buffer too small. I can look at our buffer for a second. It certainly has bytes. Update the program data account. Serialize the program data header, invalid account data. So the program data might not serialize because that account doesn't exist, that's true. But then also update the program account, program data serialize. Also that maps into an invalid account data if it doesn't work. But we do create the account for program data. So program data we create. Drain buffer account into payer before paying for program data account. That's actually smart. Creating the program data account. So program data is created, but I think the program account is what's missing. But yeah, what's the size of the program account? State, get program data address. Size of program, there you go. Size of a serialized program account, 36. There we go, easy. Why can't that just be in here? Some program account size is 36. And Lampert's, so annoying that needs to be a U in a big int here. So annoying that that can't be a number. Okay, and then when we create the program account and then deploy, will that work? And this needs to be sequential now. Yes, then it works. We can deploy a program manually. Isn't that nice? We managed to deploy a program manually, even though it was a bit of a pain with all those 180 transactions that I sent sequentially here. We can still somehow optimize that, but at least we managed to deploy. Let's see if we can also, run that. Let's say demo program. Just to see that my demo program actually works, I'm gonna do a call program instruction that is just an instruction to that program address, my program signer address. I could just put the program address here as hard-coded, but while I have the signer, why not? And then data, I need to say 1 for the instruction discriminator that we defined here, such that I call the initialize instruction. I don't have any accounts, so that's fine. And then this, I'll put it into my instruction plan. And then I should also be able to execute this. So let's demo program. There you go. Easy. 388 CU. There you go. Instruction initialize. This program was deployed manually with a kit and instruction planning. Yes, it was still a bit annoying to do that, but we managed to do this. Cool. Okay, so we could manually deploy that with the kit. And now the buffer account, actually, let's look at the previous transaction that actually did the deployment, because here we see that the buffer account was drained. It's now back to 0. Let's do an upgrade with the same buffer account, and let's do it all at once. So let's do a new version of our program. This program in version 2. There you go. It's now different. So if I anchor build, I get a different SO file. And now to upgrade my program, I'm going to do all the things that we did so far, but in one single instruction plan. So first we had the create buffer instructions. We still need to do that again. We're gonna create the buffer instructions. And we can do several plans actually. Let's not do one big sequential plan. Let's do a sequential plan of the create plan, which is a sequential instruction plan of the create buffer instructions. Then we do the write plan, which is, I'm gonna say a sequential instruction plan just because in parallel this won't work properly, of my write buffer instructions. And then my deploy plan is a sequential instruction plan of creating a program account and deploying that instruction. Could also call that my deploy instructions such that it looks the same. There you go. And then my instruction plan will be create, write, and deploy, except the deploy, we gotta change that because we're actually not creating the program account anymore. And we're also not using the deploy instruction anymore. Actually, what we gotta do, instead we need an upgrade instruction. Get upgrade instruction. What does it need? The authority was my payer, the buffer account, the program account, the program data account, and the spill account? What the hell is that? Never seen that. Spill account. Did we also have that in the upgrade last time we did that? What's a spill account? Is that the account where the... Oh, that's the account where the lamperts from the buffer come back into. Because the lamperts from the buffer don't go via the payer back to the program data account because the program data account already has enough lamperts. So we spill whatever the buffer has in lamperts that we allocate in the create buffer, that we spill back to the payer. I think that's what it is. Okay, so the deploy plan, actually I don't need a deploy plan. I don't even need a plan for that. It's just one instruction. I just put the one instruction here. So we create, we write, and then we upgrade. Simple plan, right? Simple. But is it that simple? It's still gonna be 180 transactions, but oh well. Let's go. The first one was to create the accounts. Then we send all of the write instructions. Maybe I should do this with a smaller program because really, come on, 180 transactions, that's just a bad example as well. But well, that's what you gotta do for deploying an Anchor program. Ideally, you would be able to send those in parallel and not in sequence. But since I'm cheap and I don't pay for one, the public RPC doesn't support that, so we just gotta wait for that to serially send. But yeah, ideally you would just get a better RPC and be able to do that in parallel. But the point I was trying to make here is I just put it all into one instruction plan and then I just say execute that and then it does that. I don't need to wait for the buffer to be created and then start another script to write the buffer and then start another script to deploy. I just throw it all in one instruction plan and it's fine. It will parallelize what it can parallelize, except in my case I don't let it because I otherwise get rate limited. And then in the very end it will also then directly deploy the program after it's done with all the other instructions. Bam! And that was the deployment, or the upgrade really, which deployed the program and spilled the buffer account back into the payer account. Nice. Oh, that's interesting. The upgrade. Cool. Look at that. That's also cool. We already saved one transaction because the last write only needed that many bytes, and then it was like, oh, I can still fit the upgrade in the same transaction. Isn't that cool? And so the upgrade was here after the last write. And that's what those instruction plans help us with, that we don't need to have separate transactions. It will just fit them as neatly as it can. Cool. And that way we could upgrade this program. And we could have even ran it at the same time as well. But I'm going to do that manually now. And then we see that this program in version 2 was now also manually deployed with a kit and instruction planning. Yay. Okay. And I could have easily done this instruction, the call program. I could have also put that into my instruction plan directly. So after the upgrade, I might as well call it. Although I'm not sure, let's try something. Let's do a non-divisible plan of those two instructions, the upgrade and call, and see if that also works. But maybe I want to use a little bit of a smaller program. Can I just do a Pinocchio program? Or can I tell Anchor to throw out some functionality to make it smaller? No, I'm just going to make a Pinocchio program. Okay, then we just say this program, this tiny program was manually deployed using instruction plans. And I cargo build SPF this thing, which I can almost do. And now, oh no, unresolved import. I literally copied that from here. Okay, where could that be otherwise? I just want a program that does nothing. Why is it so complicated? That's the wrong way around. But okay, maybe that at least, if it compiles. Let's see if that compiles. Yeah, okay, wow. You're making progress in the wrong direction. It was address and now it's pub key. Are you stupid? Anyway, whatever. Okay, I just want a small, tiny program, and that I have in my target deploy Pinocchio demo here. Because this is just 3 kilobytes. This should be possible to deploy quicker. So let's deploy that. So instead of this program, we're gonna do Pinocchio demo target deploy Pinocchio demo SO, and let's upgrade this. Okay, there you go. Let's go. So now it's just 3 kilobytes. Solana error transaction involved programs must not be right. Oh, okay, there we go. This transaction includes an address which is both invoked and marked writable. So I can't invoke it in the same transaction that I upgrade the program. So that's what we learned here. Wonderful. So maybe let's not make this non-divisible. Let's just do them one by one. That way, it could still happen that it does both in one transaction. Can I somehow force it that it doesn't? Can I somehow tell you that this must be distinct from this? It is in a sequential plan, but it's all just instructions. I guess I would really need to do a separate one for the call. So let's just not do the call. Let's just upgrade. There we go. 5 transactions total. And if I run it, then we can see that it is now the tiny program that was manually deployed at this address. I deployed it to the same address. But now we can do better, because for one, here there is still a little bit of space. I could already do some write instructions here, and here is a little bit of space. So I think I could optimize that to just use 4 instead of 5 transactions. And that doesn't make that huge of a difference, but this is more about understanding how I can do the instruction packing more efficiently by using this message packer plan. We can get a linear message packer plan where we use an offset and a length like we use for our buffer writing, and it accepts the total length. So basically we give it the total length, and then it will tell us, hey, here's the offset of your total length and the length you'll have available. How do you build the instruction? That's what I want to still do. Let's get such a linear message packer instruction plan. Because for now, in our writing, we always did a get write instruction for a fixed chunk size of 1000. So that's pretty much the maximum we can put for one transaction. But hey, if we want to be able to fit a little bit in here, then that could be even nicer to do that with this linear message packer instead. So let's get that. And what it takes is a total length. The total length will be our program data length, because that's how much we want to write. And then the get instruction with offset and length will be, well, basically this. A get write instruction. We return a get write instruction with our buffer signer pair. The offset, so that is now the offset inside the buffer account though. But that's okay, because that's the same as in here. So that's the same, we can just use that. And then the sub array, there's also the same. We started the offset, but then we don't take the chunk size, but we take the length that we have available. So that's that. And then we still need to do a quick fix. Oh, the length. We might not be able to do the entire length because there's more offset, because that length might be how many bytes we can still use. I don't know. Let's just try. But anyway, that will still not work because that I still need to map like this because it's just broken. So hold on. Okay, I need to do, hold on. Gotta have to do this. So first get the instruction like that, and then what I return is this. Okay, so that's my linear plan now. So I don't need that anymore. No more chunk size and stuff. Cool. So let's just try it if we, I know that it's a bit much still. So the write plan, I can do a sequential plan. I could now do a parallel because it's not that many, but really that will now be my write plan. Let's do a sequential plan of my linear packing plan. Okay, so I put this as a sequential plan. Could probably also do it parallel, but let's see. So then we create, write, and upgrade. I'm not sure about the length here. This might say, let's just try it. We probably get transactions that are too big. No. It just works like this out of the box. This is so amazing. Look at that. Look at that. And the transaction size was always 1232. Wait, what's the max transaction size? 1232 bytes. I am honestly very much amazed Wow, did it like try and then fail and then make the length smaller? How did it do that? That's magic. What the hell? How I didn't tell it how much the right instruction actually, how much overhead that all of that has. How did it do that? That's magic. Wow. What the hell? How did it do that to really max? Look at that. That's so, wow. Wow. Look, I mean, check that transaction. This is the first one which creates the account. So the buffer account, it creates the buffer account. It initializes the buffer account and then it writes as much as it can possibly write, as much as it can fit into that transaction to fully pack it. The transaction size is the max transaction size. And it somehow figured that out by itself. And so I only needed 4 transactions, not 5. And I still have a bunch spare here at the end because I was packing more efficiently. Wow. Okay, hold on. That's cool. And that was just for my small program where you really see the difference because it's now 4 transactions. And then probably in the very end, here the next one will just be writing, I guess. The next one will just be writing. Yeah, that's just we write as much as we can at offset 848. And how many bytes? Wait, let's see that raw. That many bytes. And it somehow figured out how many bytes that is exactly. I didn't tell it that. I didn't even tell it how big that... This is... Wow, I am impressed. This... Okay, and then in the very end, it probably still writes a little bit and then upgrades the program. Yeah, it writes what's left to write and then it upgrades. Holy mo... This is... Wow. Okay. Wow. And I could probably do that also in parallel, the write plan, because it's not that many. I could also do a parallel instruction plan, write them in parallel. So then those 3 really were run in parallel. But then it uses more transactions because it wants to do those in parallel. So it does the linear packing in parallel. And then this is sequentially done after the parallel stuff here. So actually, in this case, it's better to still do this in sequence because then it can fit the upgrade also still in here. From a limiting the amount of transactions perspective. It's probably faster because I can do 3 transactions in parallel, but you know, whatever. Fun. Anyway, one really last thing that I'm gonna do now, I'm gonna go back to my big anchor program and do it in version 3 and build this in version 3. And then I'm gonna deploy not my neat little Pinocchio, but my anchor program. So that's gonna be 180 something transactions again. With this more efficient linear message packer, how many transactions will it be here then? Let's see. I don't know, I didn't print it. But now it's really packing every single transaction to the max that it can pack it. How much did it pack it before? It was like to a little bit less, right? It was not much, it was 10 bytes less. So we were already quite efficient here, but now we're even more. Now we're really packing to the very maximum. And maybe like this we can save 1 transaction. But yeah, this linear message packer actually, wow, that surprised me how well that works. Because I didn't have to tell it anything more about this instruction. It seems to just figure that out with the length itself. Wow. This is really helpful. It's almost magic. I'm honestly surprised by how well this worked. It doesn't save me much here because my initial guess of 1000 chunk size was already quite good. But with this linear message packer, I can really pack it 100% efficiently because it's really, that's the max transaction size. I cannot put a single byte more in there. So yeah, that's really cool. Obviously, we can still improve how we send those transactions because that's not really done properly, efficiently. The sending of transactions is slow, but the packing is efficient. So yeah, that's quite nice. So how many do we need? 79? Yeah, 79. We saved 1 transaction. We saved us 1 single transaction. It's something. It's just 179 now instead of the 180 that we needed last times. Cool, and just like that, also this version of my program is deployed and I could demo that. that we now have our program in version 3. Manually deployed with the kit and instruction planning and linear message packing. That's quite fun. And there's more of these. There's not just the linear message packing, there's also the one for realloc message packing that helps you in the specific use case of having to extend for a certain data size, and that might need several instructions because there's a limit. But yeah, that's fairly situational. If you want something more general, you can build your own message packer where you implement the pack to capacity by yourself. But I think we're gonna leave it here. It's been a long video already, or at least I've been working on this for a while now. I'm gonna finish up. Oh man, the kit, I tell you, it's fun working with the kit. It has really nice functionality. But then on the other hand, we noticed that it's not trivial working with it, because even though theoretically it's really nice and streamlined and everything, but as soon as you have issues with, or we cannot send 1,000 transactions in parallel, when we come to those nuances, right? In practice, it can also get difficult to get the stuff to work properly. So I'm not sure. And then there's the thing with some packages of the kit, or especially some auto-generated stuff for TypeScript, still has some bugs where we're missing some stuff, and then it takes forever to figure out what we're doing wrong here. So in some cases, just manually building the instructions is still the better way to do it, but that's also a lot of effort, and not everybody wants to go through that. So not everything is great with the kit, but we're getting somewhere. And I want to push that because it's fun, and I want to tell the maintainers of it to fix those bugs and to maybe add some more features that make the parallel plans work better with rate limits. But you know, overall, especially with this message packer, that really surprised me how well that worked. And we could dig into why it works that well, or how it does that. We could look at the source. But I leave that as homework for you. I had enough for today. I need a break. But it's good. The kit and the message packers and the instruction plans, it's actually fun. And also, just looking again how we deploy a program was nice. And we once again saw that one of the difficult things in Solana is landing the transactions, because you have just a bunch of them, and then but that's a different topic. That's not the packing strategy. That's the sending strategy that we need to work on. Maybe next time. Until then, make sure you are subscribed, like this video, and watch some others. Here's the previous one in case you have still missed it. And I will see you in the next video. Solana development. Isn't that fun?